Okay, so we're going to be solving systems of linear equations by elimination. You should have the handout that goes with this video. What we want to look at first, though, is just a little review of function notation and how to evaluate a function. So just as a reminder, when it says to evaluate the function for a given set of values like this, what we're going to do is we're going to take, instead of x, we're going to put in -3 where x is in the function. Okay, so we're going to have f of -3 would be equal to -9 times -3, which is positive 27. We would have f of 0 is equal to -9 times 0, which is 0. And then finally f of 2, which is -9 times 2, or -18. So that leaves the remaining problems for you to do on your own. Okay. So our essential question for today is, how can you use elimination to solve a system of linear equations? Okay, so there's nothing to write here. You're going to be thinking, though, as you're working through, how can I answer this question? How will I use elimination to solve a system? Okay, so at the end of this video, you should be able to answer that question. All right, so we have some steps designed to help you solve by elimination. Step 1 says multiply, if necessary, one or both equations by a constant so at least one pair of like terms has the same or opposite coefficients. Okay, so that's going to be step 1. We want one set of variables to have the same or opposite coefficients. Once we've done that, we will add or subtract the equations to eliminate one of the variables. Then we'll solve for the variable we have left, and then finally we will substitute that value back in, much as we did when we were doing substitution, into one of the equations so that we can find out what the other variable is. Okay, so let's see what that looks like when we do those steps. So here we have two equations, simply called equation 1 and equation 2. And I look here, and these two numbers, right, are the same. So these already have the same coefficient. These two have opposite coefficients, okay, positive and -2. So I can, at this point, subtract these two equations, and if I do 3, take away 3, I'm going to get 0, so that would eliminate the x. Or I can add these two equations, do 2 plus -2, and I get 0, the y would go away. Okay, so it's up to me. I'm going to go ahead and show you both ways of doing this particular problem, and then you can kind of decide which you would like to do more. Okay, so first I'm going to do adding. This is going to be my add the equations together. Okay, so if I add these two equations together, the y's will go away. So I'm going to write them over down here just so I can show you. 3x plus 2y equals 4 plus 3x minus 2y equals -4. Okay, so when we add these together, 3x plus 3x is 6x. Positive 2 plus -2y is 0. So they're no longer a factor. And then 4 plus -4 is 0. So then we would divide by 6, and x equals 0. Now that we know what x is, we go back to one of the original equations, doesn't matter which one, and solve for y. I'm going to choose to put it into the first equation. So 3 times 0 plus 2y equals 4. So 2y equals 4. Divide both sides by 2. So we get 1y. So y equals 2. Okay, so my solution would be 0, 2. All right, so let's try it. What if we had subtracted? Will we get the same thing? I hope so. There should only be one solution, right? Okay, so if we subtract, we've got 3x plus 2y equals 4. Then we have 3x minus 2y equals -4. So now we're subtracting this from that one. So 3x take away 3x is 0. 2 take away negative 2 is going to be 4y. And 4 take away negative 4 is 8. So then we divide by 4, and y equals 2. That's what we got over here, so let's see. Now I can choose either equation. I'm going to choose the second equation just to show that it'll work. So 3x minus 2 times 2 equals negative 4. So we have 3x minus 4 equals negative 4. And then we would add the 4 to both sides. And we get 3x equals 0. We divide both sides by 3, x equals 0. So we did get the same point. X is 0, y is 2. Okay. So we have a couple of options, but now you've seen how to add them together and how to subtract them. Okay, so another system. Solve the system of linear equations by elimination. So I'm looking here. These are not the same and they are not opposites. These are not the same and they are not opposites. So now I've got to figure out, well, how can I make them be the same or opposites? Okay, well, let's see. These already have the same sign, and 5 times 2 would give me 10. So I could take this entire equation here and multiply by 2. That's one way I could get those to be the same. Okay. My other choice is if I wanted these two, because they've got opposite signs and 3 times 2 is 6, I could multiply this top one by 2 and then I would have opposites. Okay, so I'm gonna show you both choices, and you can kind of decide which do you like best. Okay, so the first one, if we take the second equation and we multiply it times 2, we're just going to distribute that 2 to everything in the parentheses. We get negative 10x minus 12y equals 46. Okay. So then I have my original, my equation 1, so negative 10x plus 3y equals 1, because we didn't do anything to it. And because they're the same, I'm going to subtract this. Okay, whole thing. So negative 10, take away negative 10 is 0. So that's done. Negative 12 minus 3 is negative 15y. And 46 take away 1 is 45. Then we divide by negative 15. And we get that y equals negative 3. Go to either of our originals. I'm going to pick, now I'll do equation 2. So negative 5x minus 6 times negative 3 equals 23. So negative 5x plus 18 equals 23. If we subtract the 18, that'll 0. So subtract 18, we get that negative 5x equals 5. Divide by negative 5, and we get that x equals negative 1. Okay. So our solution would be negative 1, negative 3. Okay, so that was subtraction. Let's see what we can do about adding. Okay, in order to add them, the coefficients have to be opposites of each other so that they'll add together and give us 0. Okay, so this is positive 3 and negative 6. So if this was a positive 6 plus negative 6 would give us 0. So to make that happen, we're going to multiply this entire equation by 2. So negative 10x plus 3y equals 1 gets multiplied by 2. And we get negative 20x plus 6y equals 2. Then we bring our equation 2 over. So that's negative 5x minus 6y equals 23. So then we're going to add these together, and we get negative 20 plus negative 5 is negative 25x. 6 plus negative 6 is 0, so that's 0y, or excuse me, it's just 0. And then 2 plus 23 equals 25. We divide everything by negative 25. And we get that x equals negative 1, which is good because that's what we got when we subtracted. Okay, so we need to substitute the negative 1 in for x, so we can pick either equation. I'm going to pick the second one, so we have negative 5 times negative 1 minus 6y equals 23. So that's positive 5 minus 6y equals 23. So we subtract 5 from both sides, and we get that negative 6y equals 18. Divide by negative 6, and we get that y equals negative 3, which is what we got when we subtracted. So either way, adding or subtracting, we get the same answer. Okay. I'm going to draw a little line down here so you kind of keep them apart. All right. You purchase a drink and a sandwich for $4.50. Your friend purchases a drink and 5 sandwiches, ooh, hungry friend, for $16.50. You want to determine the price of a drink and the price of a sandwich. Let X represent the price in dollars of one drink. Okay. Let Y represent the price in dollars of one sandwich. Write a system of equations for the situation. Use the following verbal model. So the number of drinks times the price per drink plus the number of sandwiches times the price per sandwich equals the total price. Okay, and we're going to let, it said let X be the price in dollars, so this is going to be our X, and this is Y is going to be our price per sandwich. Okay, so the number of drinks I got was 1, and I got 1 sandwich, so that means that X, 1X plus 1Y equals $4.50. Okay. And then my friend got a drink, so that's 1 drink, and 5 sandwiches, and spent $16.50. Okay, so there's my system of equations. Okay, so part B, subtract equation 1 from equation 2. Explain how you can use the result to solve the system of equations. Okay, so if I subtract these, okay, I'm going to rewrite them over here. So if I subtract them, what's going to happen? Let's see. Remember, I'm subtracting everything. Okay, I'm subtracting the whole thing. So 1x, take away 1x is 0. 1y, take away 5y's is negative 4y. And 450, take away 1650 is going to be negative, for sure, $12, or 12. Okay, so then we divide by negative 4, and that tells me that y equals 3. Okay. All right, so explain how you can use the result. Well, the result of the subtraction, right, we were able to solve for y. Since we eliminated the x, we solved for y. Okay, so that's my explanation. Then find and interpret the solution. So I've got y equals 3. So now I need to know what x is. So I go back to either one of my original equations. I like the first one. So 1x plus 1 times 3 equals 4.50. So 1x plus 3 equals 4.50. Well, 1x is just x. And then I would take away the 3 from both sides, so x equals $1.50. So we have 1.50, comma 3 is our solution, which means, let's see, x is 150. X stood for the price of a drink, so it's $1.50 each drink, and it's $3 each sandwich. Okay. All right, so we answered all of their questions. Yay!